Alright guys, I just saw an article here. Oh, don't tell me it's just disappeared. What is so ridiculous? That is just stupid. Alright, we're gonna have to search for it. Oh my god. Quantum theory of consciousness. Put in doubt. That's ridiculous. Just when I start the video, it disappears. I think this is it. Yeah, this is it. Luckily, I found it. Stupid though, it disappeared just because I started the recording. That's some gang stalking for you. I'm telling you, there's an evil AI in tech. And yeah, if you're a TI, let me know if you get that too. So anyway, they're doing an experiment to check basically Penrose's and Hameroff's theory of consciousness to be fundamentally quantum mechanical phenomenon. I'd say beyond that even, but anyway, it was a good effort of them to put that sort of theory forth. And so here it says, you know, they're trying to test you know, gravity-related wave function collapse, and that being part of like this theory of consciousness. And okay, Penrose and Hameroff instead argue the consciousness is based on the non-computational collapse of coherent quantum superpositions between cellular structures within neurons known as microtubules. He also says, you know, the soul is in the microtubules. I upgraded that and I said the imprint of soul may well be in microtubules. But yeah, it'll just be like an imprint of the actual soul. They reckon that while the superposition guide classical neuronal processes, sorry about that, it is the continual gravity-related collapse of the quantum states that gives rise to our sense of self-awareness. Yeah, interesting. Because you would have to have a movement, you know, for a scanning to create consciousness, right? Even that's how light works, to bounce off objects so you see things. There would have to be movement, so it's an interesting thing they've put forth. Anyway, it also involves combining quantum mechanics with classical gravity, blah, 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 curved space-time. I tell you what, I still don't understand curved space-time. Like, I looked into that years ago, and I was like, what do they mean by curved? You know what I mean? It's like, what are you talking about? I still don't get it. If anyone can tell me exactly what they mean by curved space-times and the curve of space-time, I have no clue what they mean by that. And I remember I read about it and everything. I just couldn't quite grip what they're fucking saying. Not because I'm dumb, just I swear they haven't explained it right. Anyway, predicted the collapse should be accompanied by emission of electromagnetic radiation generated by charged particles within the system as they undergo a continuous Brownian motion. It's also movement, that's random movement, related to the collapse mechanism. So they should be able to pick up some motion. Anyway, so some people teamed up with some people, they've done some stuff. Okay, they're monitoring the emissions from a cylinder of germanium. What's that, a flower, isn't it? What's germanium? Okay, I don't have my little function there. Sorry. About the size of a small tin of beans, shielded from external radiation, and by lead and copper shields, as well as 1,400 meters of rock above the lab. Okay, carrying out the experiment, blah blah blah, blah 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 blah. Result already ruled out one specific and natural formulation of the Penrose model, which stipulated that the scale of the superposition is comparable to the size of the nuclei themselves. That the scale of the superposition is comparable to the size of the nuclei themselves. Okay. So, measured lower limit of this and that, while the size of the nuclear wave function cooled to liquid nitrogen temperature, blah blah blah, molecular scale, one smaller strain of nitrogen. In each case, this and that, blah blah blah. Conscious experiment, here we go. In each case, the aim was to work out how much brain matter would be needed to collapse the wave function on a time scale comparable to that of conscious experiences. So that's interesting. How much brain matter would be needed to collapse the wave function on a time scale comparable to that of conscious experiences, typically, half a second or a quarter of a second. With a nuclear-sized superposition, the collapsing effect of individual carbon nuclei within tubuline proteins is minuscule and therefore calls for huge numbers of nuclei to act in concert. In fact, the researchers worked out the collapse of the wave function around 0.025 seconds, a whopping 10 to the 23 tubulins would need to make up the coherent state. But as they point out, there are reckoned to be only 10 to the 20 tubules. Right, now I see what's happened here. So they're saying basically that more is needed than we have in our brain. But how does that doesn't rule it out. That just means you haven't put everything into your equation. So this is this fucking ridiculous scientific reductionism that I always have a problem with. It's this reductionism that causes the problem. These considerations seem to rule out tubulin separation at the level of the atomic nuclei, they say. In the second scenario, the larger superposition scale implies the fewer tubulins would need to remain coherent. And then they worked out 10 to the 12 would do the job. Well, see, there you go. There's already a different estimate. The brain needing to maintain a mass of so forth and so on. This vastly exceeds any of the coherent superposition states achieved with state-of-the-art optomechanics, and macromolecular interference experiments. Okay. The researchers add that not all is lost. Well, they reckon that the theory seems implausible if based on the simplest wave function collapse model. It may become plausible if more sophisticated model can be developed. That's what I just said. In future, okay. Anyway, it's interesting because now we're learning about what at least they're doing to confirm and deny it.